Hello and welcome to tribetopper.com.
And you're watching this video on relative velocity in one dimension. So what do you mean by relative velocity? See, when two objects, say this is object A and that's another object B, and they are moving with different velocities. So let's VA and VB be the velocities of A and B respectively. Then the velocity of one object with respect to the other is called relative velocity. So VA is the individual velocity of A with respect to the ground, which is at rest. VB is again the individual velocity of B, which is with respect to the ground. But the relative velocity of A and B relative to each other will be different. So that is based on, if you see, there is a distance between them. So let's say S1 is the distance covered by the object A in time t. Then what will be the equation for S1? It's V1 times t. And similarly, the equation for the distance covered by the object B will be V2 times t. Now, if I subtract these two equations, what do I get? That's 2 minus 1 gives me S2 minus S1 is equal to what? V2 times t minus V1 times t. And there, if we take t common and bring it down here, we get S2 minus S1 upon t is equal to V2 minus V1. Now what is this S2 minus S1? So this arrow I've drawn to explain that this difference between the two is S2 minus S1, the gap between the two. And this position with respect to each other is going to change with time. And that rate of change of position of object B relative to object A, that is the gap between A and B, how that varies with time, gives us the relative velocity. So here we can write that this whole thing, V2 minus V1, is giving us the relative velocity of B with respect to A. Thus we can say that the rate of change of the position of object B with respect to A, that gives us the relative velocity of object B with respect to A. So therefore we can write that relative velocity of B with respect to A as VBA, just a notation. So VBA is the relative velocity of B with respect to A. It is equal to VB minus VA, as we just got, as you just saw, it's V2 minus V1 or VB minus VA. Now let us assume that A and B, they are two objects which are moving with uniform velocities, and we denote them as VA and VB. We will have three different cases. The first one is that if VA and VB are equal, that means two objects are moving with equal velocities in the same direction, then what do you think your S2 minus S1 would be? S2 minus S1 upon t, which is giving us the relative velocity of B with respect to A, would be VB minus VA, and that would be 0, which means that there won't be any rate of change in the position, because the change in position relative to each other will be 0. So that means, so change in position of B relative to A would be 0. Like you can see in the graph here. So I have the object B and A. So object A started at a position x01, B started at a position x02. Now they both started moving such that this is moving with one velocity, object B is moving with the same velocity, and whatever was the initial gap between them, it remains the same throughout their motion, and that is quite visible because the two lines are parallel. Therefore, the objects will remain at the same constant distance apart, always throughout the motion, if they are moving with the same velocities. Now we have the second case when object B is moving faster than A, that is VB is greater than VA. Then what's going to happen? It obviously means that the S2 minus S1 upon T, which is the difference of the two, that's VB minus VA, then this whole thing is positive because VB is greater than VA, and since it's positive it means it is going to increase with time, so the object B will move further apart, hence the separation between the objects keeps on increasing, and that is quite visible from the graph itself. So here if you have the velocity along the x-axis, time along the x-axis and the position along the y-axis, we see that the position of B is changing very fast and position of A is changing slower as compared to B. So the two objects, they keep on moving farther away from each other. Though they may be moving in the same direction, but if one is moving at 40 and the other is moving at 60, then 60, the one B which is driving at 60 will move really far away from A. And in the third case, when the velocity of object B is less than object A, so that means that the object which was initially behind, as you can see here, object A was initially behind object B, but after a certain time, because A was moving faster than B, it will just cross B and go ahead, and so the separation between the objects keeps on decreasing, and then it increases again, right? So earlier it was decreasing, but now when it increases again, at that point of time now A is ahead of B, so A crosses B and moves ahead, with always the gap between them going on to be increasing. Now let's find out that if two objects with whatever velocities they are moving, if they are moving in the same direction, so object A is moving along say towards east and B is also moving along east, and then we say the relative velocity of A with respect to B as per the formula we found out is VA minus VB, right? So here your theta is 0, both objects are moving in the same direction. And now if I say the objects with again whatever velocities they're moving in the opposite directions, so then we have the formula as VAB would be equal to VA minus of VB, because VA and VB are two velocity vectors in opposite directions, so it comes out to be negative of negative, so you get VA plus VB. So do you notice that the relative velocity of A with respect to B when they are moving in the opposite directions is the sum of the two? That means it's going to be much faster, and that is the case if you have noticed that when two trains cross each other in the opposite directions, they appear to be moving really fast. So based on this formula, you can find out the relative velocity of the objects based on whether they're in the same direction or in the opposite direction. So if they're in the same direction, you use this formula. If they're in the opposite directions, you would use the second formula. And so the relative velocity is really high when two objects cross each other in the opposite directions. Well, that's it about relative velocity in one dimension. Hope you liked the video.
Please follow us on Instagram, Facebook and Twitter at tripetopper.com.